You are highly welcome to this class on abstract algebra, and today we are going to continue the study of an integral domain, so which we started in our previous classes. So basically today we'll be looking at more example proofs on this topic integral domain, of which we solved a particular example in our last class. So today we will be looking at the second example proof of this on this integral domain. So what we want to prove in this class is that we want to prove that the cancellation law holds in every integral domain. So it means that if you have an integral domain, then you can perform cancellation law in an integral domain, which is similar to cancellation we can see in this ring of integers, because actually the ring of integers is an integral domain. So we also saw definition of integral domain, which will be important, which we still need to know so that we use it here in this proof. We know that an integral domain is a commutative ring with identity which has no zero divisors. It has no zero divisors. So we also saw the definition of zero divisors. We say that if you have a ring R and A and B happens to be in R with A not equal to 0 and B is not 0, and you have that A times B equals to 0. So this implies that A and B are zero divisors. So we actually saw the definition of zero divisors. Zero divisors in a ring is these are two non-zero elements of the ring. You have two non-zero elements of the ring, of which if you multiply them, you are going to get 0. That's the definition of zero divisors. So we are saying we know that is not possible in an integral domain. So which means that in an integral domain, if the product of two elements is 0, then one of them must be what? 0. Like in the set of integers, assuming x times y is 0, it means that it's either that x is 0 or y is 0. So this we know in the set of integers. So that is actually what holds in every integral domain. So we are going to look at the proof of this. So we want to prove that the cancellation law holds in an integral domain. What does cancellation law says? What does cancellation law says? Assume you have a times b is equals to a times c with a not equal to 0. So if you have that a times b is equals to a times c and a is not 0, you can cancel those a's in both sides. So which we already know in the set of integers. That's what cancellation law says. We want to show that it holds in every integral domain. So we can easily say let R be an integral domain. So if R is an integral domain and we suppose that a times b is equals to ba times c, where a, b, c is in our R with a not equal to 0. So in this place, since we have supposed that a times b is equals to a times c, where a, b, c are in your ring R and a is not 0, so it suffices to show that b is equals to what? C, for the complete definition of cancellation law. So we are going to say now a times b being equals to a times c implies, so if a times b is equals to a times c, we can move a c to the left hand side. It's changed to minus. So we have 0 left at the right. So we can say AB minus AC is equal to what? 0. So, and it happens that A is common, we can factorize it. So this implies that A, then open bracket, what is now remaining here is B minus, and what is remaining here is C, is equals to 0. So this we did by factorizing A. So we can continue on writing this side. So if we have that A, we are having here A times open bracket B minus C close bracket is equal to what? 0. So since R is an integral, domain, R has no zero divisors. So since R is an integral domain, we know that R has no zero divisor. This is what we know. Now we have the product of two things are giving us 0. We have A is timesing the quantity we have inside this bracket. So we know that normally if it is in the set of integers, assuming for instance I have x is multiplying something in a bracket, so it means that, and you are having equal to 0, it means that either the x is 0 or the quantity you have inside the bracket is 0. So now, since the ring is an integral domain, the same thing happens for every integral domain because the set of integers is an integral domain. So if this product is giving us 0, then one of them must be what? 0. But we have already said that A is not 0. So since A is not 0, since A is not equal to 0, so this implies that B minus C must be what? 0, because this is an integral, we are working on integral domain. So if this happens, we can move minus C to the other side and we easily see that B is equal to what? C. So with this, we have gotten the complete proof for this, because it shows that cancellation law holds. A has been cancelled at both sides. So we have seen that cancellation law holds in every integral domain.